Alright, let's take a look at section 2.3, which is postulates and diagrams. In this chapter, we're not really learning anything new other than taking a lot of the facts that we learned in chapter 1 and then writing them as a postulate and understanding how they apply in our statements here. So let's start off. We have line perpendicular to a plane. Hopefully we realize that if a line is perpendicular to a plane, this line is going through a plane at a 90-degree angle. So it would be going straight down. So if we were to draw right here a plane, and you can name it plane P or letter of your choice, maybe the letter of your name, first name, right? Let me go ahead. So if I draw myself a plane right here, and I draw a line, and I want it to go straight down, and just to make sure that we know that it is perpendicular, we could add one more thing, and that is this little red box, which is our right angle symbol. Then I know that this line is perpendicular to this plane P. And we go ahead and label this line L. All right. So now let's take a look at these postulates. Remember, I've been trying to stress to you that you need to make sure you memorize all the postulates and everything that we've gone through. We have specific names for them now. The numbers are not so important, but the names actually are. It says we have the 2-point postulate. Through any 2 points, there exists exactly one line. Okay, so remember, 2 points make up a line. We talked about that a lot in chapter 1. The next postulate, line point postulate. A line contains at least 2 points. So it's pretty much postulate 1 and 2 are 1 and 2 are very similar. Right, the first one said through any 2 points there is exactly one line. In a line, there's at least 2 points, okay, so there could be 3 points, 4 points, but it has at least 2 points. If you think about the two statements, the order has changed. And remember, when we talked about the order being changed, that right there would be what type of a statement? That was in 2.1. If you said it was the converse, then you'd be correct. Okay, so that's when we change the statement, and it still holds true. Let's take a look at line intersection postulate. 2 lines intersect at exactly 1 point. I tried to stress that a lot. Chapter 1. 3-point postulate. Through any 3 non-collinear points, there is exactly one plane. Okay. 3 points, 1 plane. 1 plane has at least 3 non-collinear points. And that's the plane point postulate. Okay. Once again, you may say they sound exactly alike, which is partially true. But the order in which the statement is written is different. So it's important to look at a diagram, assess what kind of conclusion can I make based off of the diagram. 2.6, plane line postulate. If 2 points lie in a plane, then the line containing them lies on the plane. So they're saying, look right here. If points D and E are on this plane, then this line DE is on that plane as well. Okay. And remember, it could be any 2 points. I could say right here, line DF. Okay, even though you don't see a line, okay, so this is important. Even though you don't see a line going through points D and F, remember, through any 2 points, there exists a line. So I can say that line DF does exist. I could say also the same thing between points E and F. Through those 2 points, there can exist a line. even though it does not appear in the diagram. Looking at 2.7, plane intersection postulate. Two planes intersect, then their intersection is a line. Very important postulate right there. You may see it on your tests and quizzes. Okay, very good one. Two planes intersect at a line. And right here, they're trying to show you what that line is with line L. So, we're going to put all that together into practice right here. We're going to state the postulate illustrated by the diagram. If I look at number 1, I see 3 points. It says if A, B, and C, right, 3 points, then all of a sudden we have a line going through those 3 points. Well, which postulate would that be? Points making up a line, we have the 2-point postulate. Remember, 2-point postulate through any 2 points, there exists exactly one line. All right? Number 2, if, and I see right here, I've got a plane, I've got plane S, I've got 3 points, but then I have a line going through 2 of the points. What would be the best postulate for this? We have the plane line postulate. Right? In the plane line postulate, we have if 2 points line the plane, then the line containing them lies in the plane as well. All right, moving along. Now, we have to examine this one diagram right here on the left to help us answer numbers 3 through 6. Use the diagram to write an example of the postulate. So we have several different answers here, but I'm looking right here, the 2-point postulate. All right, remember, 2-point postulate says through 2 points, there exists a line. I can see right here, specifically with B and C, right? So I could say points B and C make up line L. All right, hopefully that makes sense right there. There we have number 3. For number 4, the line point postulate. In a line, there exists exactly 2 points. So I could say right here, looking at our example, that line L that contains 2 points, those points being B and C. Take a look at number 5. We have the plane point postulate. In a plane, there should be 3 points. What's the letter of this plane that we're looking at that makes most sense? It would be the one right here, which is plane P, right? And it's got these 3 points. So we can go ahead right here, say plane P has, remember, it's got to be 3 non-collinear points. And those points are A, B, and C. Remember, if they're collinear, then it just happens to be a line, not a plane. Okay, so once again, 3 non-collinear points. Moving along to number 6, the plane intersection postulate. I've got 2 planes right here. I've got planes P and Q. And they intersect at a line. And that line right here is line K. Okay, so plane P and Q intersect at line K. Moving along. Looking at number 7. We have RS bisecting at KL. Let's sketch a diagram of the description. Alright, so we have segment KL right here. I'll go ahead and have K to L, and we have R to S. That ray is bisecting, so at point R. So this has to be point R. We got our ray over here, and we have S. The last thing is, remember, it's bisecting it, so I got to make sure I notate that in my diagram that's being bisected. All right. Let's go to number 8. It says in plane U, intersecting CD at point E and point C not on plane U. This one's a little, they got a lot of things going on here. So we have right here in plane U, so let's go ahead, I'll draw myself a plane. And remember, the plane actually goes on infinitely, although it may not look like it right here. So line AB is in the plane. So we need these 2 points, right? I got A and B. I'll go ahead and draw that out, line AB, and then intersecting CD at point E. But point C is not on the plane. That's interesting. Well, if it's not on the plane, then let me go ahead and draw a point that happens to be outside, and there's point C, and it's saying intersects at point E. So I'll go ahead and make a line going through right here. Let me be more specific. AB is on plane U, intersecting at CD at point E. So point E actually needs to be on this line right here because it all intersects, and that's where E is going to be doing something like this, because E is on the plane while C is not. All right, so there's an example of that in number 8. Next up, number 9, 10, 11, 12, 13, and 14. Taking a look right here, use the diagram to determine whether you can assume the statement. We says planes AB intersect at EF. Okay, remember 2 planes intersect at a line. EF is right there. That looks to be good. So that would be yes. All right, I'm looking right here. That's the line, and we have planes A and B. Number 10, points C and D are collinear. Okay, points C and D are collinear. Yes, remember, 2 points make up a line, even though, once again, it doesn't show it, but 2 points on the same plane make up a line, or 2 points in general. Number 11 right here, we have HJ, ray HJ. We have it right here, and ray or line ID are perpendicular. That right there is yes. I see the 90-degree symbol right here. Okay, important. Number 12, line GD is a bisector of EF at point D. So if I look at EF, point D, I see the little symbols right there telling me that those are 2 congruent segments. So that right there would be yes. Number 13, we have segment IH. What do we have? Segment IH right here is equal to segment HG. That's a big no. Remember, they don't have any symbols to show that. If they had the congruent symbols like ED and DF, those 2 segments, then we can make that statement. Can't do that right here. And then finally, number 14, angle HJD. So we have H, J, and D. They're talking about this angle right here, and angle HD J. They're saying that those two angles are complementary angles. That's a yes. Remember, I told you right here, a triangle has interior angles of 180. I know that right here, see this? That's 90 degrees. So that means that if I subtract 90 to this, what's left? 90 degrees. That means these two angles right here have to add up to 90. All right? So that's why it says that we can assume that those two angles, I don't know what they are, but they do add up to 90 degrees. All right? And that's why this statement right here is true. Because remember, complementary angles are two angles that add up to 90. All right, so that concludes section 2.3.